Hi everyone, this is lecture series 1 under Computer Networks Lab dealing with the first experiment. So before going in detail about the first experiment, let me explain what are the part A experiments available in Computer Networks Lab, then move into the experiment 1. Please do like, share, subscribe and comment. So in part A, you are going to simulate some experiments where you will be implementing point-to-point network with number of nodes, giving duplex link between the each nodes and check the network performance. And the second one is you will have a 4-node point-to-point network, and the point-to-point nodes are given as N0, N2, N1 to N2, N2 to N3. So the path is also clearly given in the question. Now you will be applying the TCP and UDP, that is the protocols, to determine the number of packets that is traveling from one end to the other end, that is from one node to the other node. And the third experiment is you will be implementing an Ethernet LAN having particular nodes, and through that you will be calculating the error rate and the data rate. And the fourth program is you will be implementing Ethernet LAN using many number of nodes. The nodes can be decided by S. So using N nodes, and you will be applying the number of packets that must travel through that particular node, and you will be obtaining the window, that is you will be obtaining the packets that is at the destination through congestion window. So it is a kind of protocol, or it is a kind of algorithm that you have to follow. And finally, the fifth experiment is using wireless LAN, how the performance parameters is measured when the nodes are set up and the packets are transferred between the nodes. And finally, the last experiment under part A is you will be using link state routing algorithm. It is an algorithm which finds the data to be routed through different nodes. So I'll be explaining all these programs one by one, and today we'll be seeing the first experiment, which is nothing but implement a point-to-point network with 4 nodes and duplex links between them. Analyze the network performance by setting the queue size and varying the bandwidth. So now, what exactly we have to know is we are working in ns2 tool, which is used in Ubuntu. Okay, so now here first, when you open the Ubuntu window, you go to the terminal and open a screen. Ubuntu and ns2 tool, when you open, you will be clicking on the terminal and you start typing the program. So now how to start with the program? So the first line, set ns new simulator. So this is nothing but ns is an object. It is an object under the class simulator. So simulator is a class. So you would have learned in C and C++ declaration of class, declaration of object, or declaration of operator. So the same thing you will be following. So here class is nothing but the simulator. Under that simulator, you are creating an object called ns, which is having an operator new. So it means that you are opening a new simulator. You are setting up a new simulator to write the program. So now after this first line, generally we should create two things. One is trace file and nam file. Trace file and nam file. So trace file and the nam file is one which is going to give you the output. Trace file is the one which is going to trace the number of packets that is traveled from one end to the other end, and nam file is nothing but it is the animation file. NAM is nothing but animation file that you will be seeing how the packets is transferred from one node to the other node. So you will be setting up trace file and nam file. Now here you see you are setting a file under trace tr. So tr is nothing but the trace file. What is this w? W is nothing but you are creating the trace file where it is in writing mode. Writing mode, reading mode. Reading is you will just read, you cannot make any changes. W is you can write, and if there is an error, you can change the data inside the program. So you are using W. So this lab1 is nothing but the name of the file I am giving. So this lab1 can be of anything, experiment1, ns1, anything. Okay. So the same way you are setting the nam file also. That also should be in the writing mode. Now, see, you can see the dollar symbol everywhere. So what does the dollar symbol means? So dollar symbol is nothing but you are going to add the content of ns. So you have created the simulator. Now in the simulator, you're going to add the contents in the form of trace file or in the form of nam file. So when you keep on adding the contents, you will be using dollar symbol. So dollar symbol indicates the contents of ns. Okay. So now nam and trace file is set up. Next, you have to keep explaining how the nodes is being established and what are all the protocols you are going to put into those layers and how the packets is dropped out. Okay. Now you can see here, this is the finish part. This I will come explain you later. Now, after setting up the trace and the other file, nam file, you have to set up 3 or 4 nodes based on the questions given. So here they have given point to point network with 4 nodes. So 4 nodes means I have to set 4 nodes, 0, 1, 2, 3. So I have set up 4 nodes. For setting up of 4 nodes, I will write set n0. Now that node will have, you can add the content to that particular node. How many packets can be sent? What is the limit it can be done? So all those you can keep doing. So I have set the node now, 4 nodes. Now see here, that node has a content called as duplex link. So you are setting up a node 0, node 1, node 2, node 3. Now the communication between node 0 and node 1 is having a duplex link, which means you can send and receive data at the same time. Okay, you can either both the sides, the node 0 will also send the data at the same time. Node 1 also can send the data to node 0. So this is called as duplex link. So you're setting up a duplex link between node 0 and node 1. Okay, now this 0.3 MB, what it means is you are going to determine the bandwidth. Bandwidth is nothing but 0.3 MB. Then 10 ms, it is nothing but the receiving time. Within 10 ms, the data from N0 should reach N1. So the limit, within 10 milliseconds, that data will be transferred to the node 1. Okay. So this is the drop tail method that you are using. It is a type of queue. That is how much data will be in the queue in a particular node to transmit and receive the data. So for that you are using drop tail method. And here this you are putting it in. See, this doesn't comes under the program because you have put hash. Hash is nothing but here for bandwidth 0.3 MB you are calculating. Likewise, you have to calculate for 0.457. Likewise, you have to calculate. Now here I am just calculating for 0.3. So like this, you are setting up 3 duplex link between node 1 to node 2, node 2 to node 3 with same milliseconds. Milliseconds is 2020, and with the same bandwidth you're going to set up. Now the node is set up. You have determined within how many seconds it should be received and transmitted, and what type of queue you have chosen. All those you have now selected. Now the queue you have selected it as drop tail. Now how much must be the queue length? See, you cannot keep on sending the messages. Obviously, the error rate of the messages, if the traffic increases, the message will be missed out. So you have to set a queue limit for the particular nodes where the data is getting transmitted. So this is the queue limit, 20. So only when the queue limit between node 0 to node 1 is 20 means more than 20 packets, it is not going to accept any more packets. Even though if you dump more than 20 packets, only the 20 packets will be received by the node 1 and all other packets will be missed out. The queue limit is only 20. So for each of the nodes, you will determine the size limit 20. Okay, after determining all these, you have to set up an agent called UDP. So you can either use UDP protocol or TCP protocol. Okay, now the transmission is taking place. So under here, agent is a class, where under class you are setting up a subclass called as UDP. So under a class, you are setting up a subclass, determining this is the protocol that has to be followed. So that protocol is determined for all 0. That is, here why 0 is because from the node 0 only the packet is getting transmitted to the other nodes. So I am going to set up only N0. So which will be UDP 0. After that, this is the transport layer. Next will be the application layer. So when it is going to establish and tell you the amount of packets that is dropped, then that will happen in application. So here also application is a class under which we have created a traffic. So we are going to determine the traffic and we are going to tell how much packets is dropped out. So for that, I am initializing UDP 0. So for node 1, I am initializing. So the packet size, the size of the packet should also be mentioned. How you have determined the queue limit, how the bandwidth limit is determined, the same wise, how much is the packet size? 500. So this packet size, one packet size will be of 500 will be sent first. After that, you have to ensure that that is received by node 1. So that is the interval 0.005. So within that milliseconds it will reach, and after reaching the node 1, it should ensure that your protocol should ensure that the packet is reached to the node 1, and it will wait for 0.005 millisecond and then send the next packet. Okay, and this null is done is if there is any packet that is sent is null, has no value, then that also it should accept, because if it comes within the queue limit, then that data also should be accepted. And after that, I am going to determine the start, stop, finish function. So now I have determined all the protocols, all the queue limit, everything. Now I have to start and stop to see how many data is being transmitted. So I am giving start and stop. Now finish. So for finish, you are coming here. So for the procedure finish to happen, you are globally taking all the data available in the queue. That is flush trace. You are going to completely flush all the data into your NS. Okay, after flushing all the data, you will be closing the data. That is, the queue limit is closed and the particular file will be created. That is, animated file will be created. Okay, then you will be giving run. Now all these will be typed in the terminal, right? How it is being typed is, first you have to open the terminal and give VI. This NS1 is the name I have given to that particular experiment. That NS1 can be of any type, experiment 1, NS1 or EXP1, any name. Okay, so the experiment name .tcl, because we are using TCL, right? So .tcl. Now the terminal will open where you will be completely typing all the program. Okay, after typing the program, you have to click escape : and click WQ. So escape : is nothing but you are saving, closing and saving the file. Okay, you're saving and closing the file. Now you will be typing. So once this is done, you will be going to this terminal again where you have typed this. There again you will type NS, the experiment number .tcl. So it will be showing, it will take you to the animated file, and you can see, you can play and pause the data, and again you have to come to the terminal and see how many packets is being dropped. The answer will be given. The number of packets dropped is 8, is 10. Okay, based on the queue limit you have given, it will give you the output. Hope you have understood. The other experiments will be explained in the upcoming series. Thank you. Please stay tuned for more information.